Hey students, in this video I'm going to explain how to do the Gaussian elimination method. We're going to use the previous knowledge that we have. For example, the system of equations has to first be converted into an augmented matrix, which is just writing the coefficients. So 1, 1, 1, 2, 3, 7, 1, 3, negative 2, but also the constants. So 3, 0, 17. Usually the matrices also have a vertical line here, and that just represents the equal sign. That way you know that these numbers on the right side are the constants, and these numbers on the left side are the coefficients. Before we continue, I just want you to understand why we're using the Gaussian elimination method. If you recall from the substitution method is best used whenever you have an equation that has all three variables, and then a second equation that just has like two variables, and a third equation that just has one variable. This is best for substitution method because you can easily identify one variable, and once you have it, you substitute it into the other, and then that helps you find the other variable. And once you have that, you substitute these two values into that equation to solve for the other variable. So this is ideal for substitution method. As we do elimination method, you're going to start noticing a pattern. The whole purpose of doing all the math that we're about to do is to make these equations to look like that. And you'll see in a little bit. So in order for that to happen, your goal is to make this matrix have 3 zeros in this corner, which is the space that we don't have any equation or letter here. And then the numbers that you have right here really don't matter. I know there are times that I have mentioned about maybe putting ones in this diagonal, but I'm going to take that back and emphasize to only focus on the zeros and don't worry about the ones right now. If you can get this to become zeros, you are able to use substitution method to solve. So for example, you are needing to choose which zero to concentrate on first. I strongly recommend you to look at these on the left side first before you do this one right here on the bottom. So if we look at these two on the left side, doesn't matter which one you pick first, like as long as you just make them zeros. So let's start with the middle one. How can the 2 become a 0? Well, we can make this a 0 if one of these becomes a -2. So again, it's just randomly picking which one you want to work with. So we're going to work with the top. This is going to be row 1, row 2, row 3. And we're going to use the top row and make this number 1 a -2. So it can help you cancel this +2. And you're going to annotate that row 1 needs to be multiplied times -2 to make this a -2. And after we multiply the entire row times -2, we're going to add it to row 2. This will create a new row 2. So because we're creating a new row 2, we're going to rewrite the matrix that we have and only copy down row 1 and row 3 because we're not changing those rows. Okay, and now the process of what will be in this space right here for row 2 is this part. So we're going to multiply row 1 times -2, all of these numbers at the top times -2, 1 times -2, 1 times -2, 1 times -2, and 3 times -2. So these numbers come out, and then we're going to add it to row 2. Row 2 is right here, so we're going to put a 2, a 3, a 7, and a 0. And we're going to go ahead and add this downward, like an elimination method in algebra 1. And the result that we get here is what's going to go in this new row 2. So here we're going to have 0, +1, and go ahead and make sure you're writing this as you get these. -2 and 7, that will be +5. And -6 and 0, that's -6. Okay, so now we have that 0 right there, and we want to make this other one another 0. So now we use the first row and focus on making that a negative 1. So the annotation of the process will be row 1 times negative 1, and we're going to add it to row 3 to make a new row 3. So because we're not changing row 1 and row 2, we're going to copy those down to 1, 1, 1, 3, 0, 1, 5, negative 6. And in this space, you're going to go ahead and write down this process. So row 1 times negative 1, all of the numbers in row 1 times negative 1. So that's negative 1, negative 1, negative 1, negative 3. And we're going to add it to row 3. So 1, 3, negative 2, 17. The answer we get here is going to go in this part. So we're going to have 0, 2, negative 3, and 14. And that looks like a 3, so let's put a negative 3. Okay, so then now the only 0 that's pending to change is this 2 right here. So in class, I recommended you to now not use the first row, because if you merge the first row with any of these, the zeros are no longer going to be there. So let's just focus on that first, these 2 rows right here. And how can we cancel this 2? So we need a negative 2. So we're going to look at row 2, and we're going to multiply row 2 times negative 2, and we're going to add it to row 3. And that's going to create a new row 3. We're not changing row 1 and 2, so I'm going to go ahead and copy those down. 1, 1, 1, 3, 0, 1, 5, negative 6. And then let's go ahead and write the process. Negative 2 times row 2, so 0. Negative 2 times 1, negative 2 times 5, and negative 2 times negative 6. And then we're going to add row 3. So all of the numbers on row 3. 0, 2, negative 3, 14. We're going to add downwards, and then we're going to get 0, 0, so those go here, and negative 13, and 26. Okay, so then this is a part where I'm not going to force you anymore to turn all of these into 1s, because we can still get the answer from here. And technically, what I want you to understand is that this bracket right here of the matrix represents a system of equations in the form of x, y, z, and equals a constant. So that's 1x and 1y, so plus y, plus z, equals 3. So now let's practice rewriting this entire matrix back into system of equations. So that second one, there's no x, so we're going to have 1y plus 5z equals negative 6. And the last part is negative 13z equals 26. So this is the system that we originally started with, but what we did is we did all this Gaussian elimination process to now rewrite it in this form. And in this form, as I mentioned earlier, is what you want in order to use substitution method. So now we're going to use substitution method to solve for all the variables. We're going to start with the one-step equation. So negative 13z equals 26. We're going to divide both sides by negative 13. And that will give you z equals negative 2. Okay, so then now let's use the second equation and plug this in or substitute this for z. So we're going to have y plus 5z equals negative 6. Y plus 5 times negative 2, because we're substituting that negative 2 for z, equals negative 6. And then we solve for y. So we distribute. So y plus negative, so we could just put minus 10 and negative 6. And y minus 10, we need the 10 to cancel, so plus 10, y equals 4. Okay, so now we have z and y, and we're going to now find x. I ran out of space, so I'm going to turn the paper real quick. So we're going to have x plus y plus z equals 3. And here we're going to have x plus the y value, which is 4, plus z, which is -2, equals 3. And we're going to have combine like terms. X plus 2 equals 3. Subtract 2 from both sides, and x equals 1. And that results in your solution. So don't forget to put the solution in order. You're going to have x, y, z. So we're going to have 1, 4, and -2. Okay? I hope this video helps.